Now we are going to start Chapter 7, Object-Oriented Design. There are many topics here. Among them, Section 7.3, Static Member is very important, and 7.8, Method Overloading is very important. Okay. First, I want to talk about program development activities. Okay. So, the creation of software involves these 4 steps. At first, you need to establish the requirements. Okay, and then you create a design. What does this mean? It means that you will decide which class you need. Okay, and then how many methods do I write? Okay, so these are designs. And next, once you've done your design, you will implement the code. Okay, so you actually write the code in the step 3. And after finishing writing code, you will test your implementation. Okay, so this is just a step. You do your homework. At first, you will read a question. Okay, and then you will find out what requirements, what you need to do. And then you think which class I should write and which method I should write. Okay, you will think like that. And after that, you will write a code in Java. Okay, and you will test your code, and your test is okay, then you will submit your code. Okay, but these activities are not strictly linear. They overlap and interact. Okay, so sometimes while you write the code, you think maybe I need some more classes. Then you will modify your design a little bit. Okay, so these are not strictly linear. Requirements. Software requirements specify the tasks that a program must accomplish. That is what to do. Okay, what to do. So you need to know what is the input, and from the input, what output we should have. Okay. So careful attention to the requirements can save significant of time and expense in the overall project. Here is an example of the requirements. So this is the question. Write the program that prints out the student's information and the course each student is taking. Okay. So these are student information. The student number, name, department, major, and course number. And here is the course information, course number, and the course name, course title. Okay, so these are input. Okay, these are input information. So we can think input like this: student ID, name, department, major, and course number. So it means that Steve, this is the Steve ID number, and computer science major, and Steve takes 145 course. Okay, this is course number. And this is another table. Course number means course ID. Okay, and this is the course title. So 145 is Java programming. Okay, then we need to output Steve majors in computer science. Steve here majors in computer science, and he takes 145 course, right? So 145 course is Java programming. Okay, you see here. So Steve takes Java programming. Okay, likewise the other 4 students information will be printed out. Okay, so these are requirements. This is the given input, and from the given input, we required to have this output. Okay. Next, design. A software design specifies how program will accomplish its requirements. Okay, so a software design specifies how the solution can be broken down into manageable pieces and what each piece will do. In an object-oriented design, we should think about what kind of classes and objects we need, okay, and specifies how they will interact with each other. Okay, among objects we need to have some interaction. And row-level design details include how individual methods, okay, and how the individual methods will accomplish their tasks. Okay, so in Java, you need to have classes. You need to determine which classes you need, okay? And under the class, you need to think about which methods I have, okay? So that is the design part. I think now you are accustomed to UML diagram, right? UML diagram is the just design part, okay? So you will determine which class I should write, okay? Like this, there are 3 classes. And in the class, you will determine the attributes and constructor and setters and getters. And if you need more, you will have more methods, okay? So this is the design part. And the important thing is that this interaction, okay? This relation is very important. The relation between classes is very important, okay? So your UML diagram should have every classes you need in the project. And in the class, you have attributes, methods, and relations between classes. This is the UML diagram in design part. Now, implementation activity. Implementation is the process of translating a design into source code. Okay, so you will write down the code according to the UML diagram. Novice programmers often think writing code is the heart of software development, but actually it should be the least creative step. Which step is the most creative, you think? I think it is the design part, right? You need to spend a lot of time for designing UML diagram at the first place. Almost all important decisions are made during requirements and design stage. Okay, so you must think, given input, what should be input, and given input, you should determine what is the output. And according to the input and output, you must design UML diagram. Implementation should focus on coding details, including style guidelines and documentation. So implementation is just a step for writing a code. Here is the implementation of the UML diagram we just have seen. Okay, we just see the one UML diagram that has a student, course, and student course class. There are 3 classes. So this is the first class, a student. As you see here, like other classes, it has attributes, constructor, and setter methods and getter methods. Okay, usually we have these members in the class. And this is course class. Course class also has an attribute, 2 attributes, and constructor and setter method, getter method, and usually we have public string toString method like this. Okay, public string toString method. And this is a student course class that has a main method. This is a main method, so we call this is a driver class. So I make 2 arrays. One is for storing student objects, and the other is for storing course information. Okay, so there are 5 objects, student objects, and 3 course objects. Then I will find, if this is 145, then 145 course is Java programming. Okay, so I want print out the output. Means that the output is that Steve, majors in computer science and takes Java programming. Okay, my output should be like that. Okay, so using this number, I will find which title is 145. I will find that from here. Okay, so this is the main part. At first, this is just for printing out, and then I will loop, go through from the first element of the student object and then up to the last element like this. So I will get student object information. Okay, and using the subject number, I will find the title of the subject. This is that part. Okay, and this is the final output of the result. Okay, I think you will understand this code. This is not that difficult. This is the last step, last activity. Once you finish your implementation, you need test, right? You need test. Testing attempts to ensure that the program will solve the intended problem under all the constraints specified in the requirements. Okay, so a program should be thoroughly tested. This is very important. Thoroughly tested with the goal of finding errors. Okay, so at first you need to find compile errors. Okay, so testing means that after you find the compile errors and fixing it, then you will test your code works correctly. That is the testing. And if you have some problems with that, then usually you do debugging. Okay, debugging is the process of determining the cause of a problem and fixing it. Okay, we will visit the details of the testing in the later in this chapter.